Hello, we are here from the Mozaic Works studios, and we thought about creating a new series of videos that touches on challenges in modeling various concepts in your code. This is something I've always wanted to do. I think it's a fascinating area of software development that we rarely discuss.
And there are some more complex topics that one of them we're going to tackle today about date and time, but also there are some that seem simpler but aren't that simple, in fact. So what about date time? It's your favorite topic.
It's my favorite topic because I started to notice when I discussed to programmers that they don't know a lot about date and time. A lot of these things that we don't know end up as bugs in the software that we produce. And there are many instances of applications that stop working, typically due to date time. So often during leap years. This is very common. 29th of February is usually a dark day.
Yeah.
I think Microsoft Azure was down at one point during the whole day.
Yes, 2012 or something like that.
AWS was down 1 year on 29th of February. Another point is when you switch years. So when you change the year or you change something like this. It happened, for example, with Microsoft Zune, which used to be an audio player, and it stopped working on 1st of January. And due to the change of the year, who would have thought about it?
Yeah, I think we see and we discuss about these things, especially during the unit testing workshop, and each time programmers in our classes are amazed that date time is that complicated, and sampling, finding enough data for testing the date is huge. It's very complex, even for something very simple that doesn't need very complex date time changes or more time zones and so on. Even like that, it's very complicated to test date time.
Yes, and because of that, I thought about going through a few typical topics related to date time, from simple to more complex. We'll start with the very simple ones and we'll end with a very complex topic related to date time.
And all of those come from clients we worked with, or different products that we know about. And yeah, even for us, some of them seemed weird in the beginning, but here we go.
Yeah. So first of all, it's important to know that different cultures have different calendars. Yes. This is, let's say, the simplest problem to deal with because most of these calendars are actually now part of libraries. So if you are using a right DateTime library, that library will know how to deal with those calendars. However, sometimes it's important to also test for these things. So for example, you cannot assume things. You cannot assume that a week starts on Sunday or on Monday, because in US a week starts on Sunday, but here in Romania we start on Monday. So that's a very common thing. Another interesting thing was for how long is a month?
Yeah.
If you have the concept of month in your product, what does it mean?
Well, it doesn't mean a lot. It depends on the business domain. If you just refer to the basic calendar, it's just either 28, 29, 30, or 31 days, which is confusing, right? But can be more.
Yes, and so it depends on what month are you talking about, and if you try to do any kind of arithmetic with the date time,
it's impossible.
So something like 1 month plus 2 days, how much should that be? How much is that? Or 1 month plus a week? Any kind of arithmetic like this is fairly complicated. But even more than that, I worked on a medical application for a GP from Belgium, and when we asked about the concept of month, it turns out that if you are talking about drug prescription in Belgium, a month is precisely 28 days.
Which is makes sense just because of that. It's difficult to make arithmetic computations, so it's just for making sure you have a fixed month. But for sure, this is surprising for anyone.
And it also helps, it makes a lot of sense when you think about it, because it helps with standardizing the drug boxes. How many pills should you have in a box?
And the recipes.
And because the month is 28 days, then the boxes will have 14, 7, 14, 28, 56, maybe double that, 112, but that's it. So that's how many pills you have, and that's how you standardize basically the drug boxes. So the first lesson from here is don't assume things and ask, how long is a month? When you talk about months, what do you mean?
It seems like a weird question, right? But still, we need to ask that.
Yeah, and I assume it's different from banking or for paying rent or for utilities.
Yes.
You have different types of things. The next one, which is it's fun, and we forget about it because it comes only roughly every 4 years or so. The leap year.
Yes, the leap year.
So from time to time we have a 29th February, which also happened this year. And there was a funny tweet that I think you saw as well.
Yes, so if you want to buy a 4-year subscription but just pay for 1 year, buy something on the 29th of February.
Yeah, so in case you're doing a kind of subscription-based service and you are responsible for the code that computes when to renew the subscription and when to charge people for that, be very careful if it starts on 29th of February.
You need a test for that, for sure. I mean, any type of subscription would need a test for 29th of February.
So maybe you should use something like the end of the month, which is computed, and you use the calendar library for that, or you use something like a fixed number of days or anything around this area, but you have to figure out what to use. It's not as easy as it seems. Related to that, an even less known thing about DateTime is that from time to time we have a leap second.
Which, well, for typical application is not that important, but for critical applications is essential.
There's one case when you need to pay attention to it, and this is in case you are logging. In your log files, if you have a timestamp, you may be surprised to see that your clock just went back inside your log file. So then, maybe you need to pay attention to that. By the way, this happens because of an obvious thing. Once you start thinking about it, so a year is defined by the movement of the Earth around the Sun and by a complete revolution, while a month is defined by a day is defined by a complete rotation.
Yeah.
And those two don't have to fit. Exactly. So the number of rotation doesn't have to fit in the whole revolution because the two are completely separate movements. And that's why we need to adjust months and leap years, leap seconds, things like that. The next one, which is again fun, daylight saving time.
Which now it's also a subject of debate if we still need it. So it will be even more complicated because now you were used to having it, but...
Well, I guess some people hope that we'll switch to UTC for everybody and this will solve every little problem that we have, which might be a good idea, but honestly, I can't say. I don't have a... There are so many things that depend on this that It's very difficult. So when you have daylight saving time, once again you have the case when now the hour is 1 a.m. or 2 a.m. and suddenly it's 12 or it's 1.
Yes.
Or it's on the other side, it's 2 a.m. and now it's 3 a.m. And in case you're using the local time to save logs or process transactions or whatever else you're doing.
Yeah, that would be a nightmare.
Imagine you have, for example, a transaction that comes on 2 a.m. that says pay this, and then you get another transaction that's on 1 a.m. that says give me some money.
Yeah, sounds fun.
And then you run those in a wrong order. It's not easy to recover from that.
Yeah, so the basic rule here is to use UTC and not use the local time or use the server time, but even like the server time should have UTC. That's the simple approach.
And this takes us to time zones, which have the similar problem. We've seen situations where you have the following case. You are starting a new client server application. Let's say it's a web app for simplicity. You deploy it in your local time, right? We are in Bucharest. Let's say you deploy it in Bucharest. You have your local server. So then you don't think about using UTC. You just use the local time everywhere.
Yeah.
And then you decide to go to cloud and you move your server to Germany or UK. And suddenly you have a 1 hour, 2 hours difference. Another common thing that I've seen here, because you want to show the time or to use the time that for the users from their own time zone. How do you do that? You save in local time.
Yes, but you change then the shown time. Yeah, it's a mess.
It's a mess. So then the best way to deal with that, and we've actually seen some teams struggling with this. So when they started saving everything in the local time of the users, but then they didn't capture what the time zone of the user was.
Yes, so you don't know.
So you don't know what time is actually things happen, and when you try to combine those, everything is...
Yeah, it can be anything, so you don't have time anymore.
Therefore, the best solution here is to use UTC on the server. And if you want to have the date for each user and the time to each user to see it in their own time zone, save the time zone for each user. And that's part of their preferences or whatever. Yeah. And this is what you see in most applications that we use on the web. You have somewhere an option where you select your time zone.
But when you travel, that's fun because it happens to me. Even big companies do that. You travel and then you go somewhere else. There's a difference in time, and you see your old date and or your old hour. It takes maybe a few hours or even a few days to change, and then you're back. And when you're back, you have the other hour, and it takes a few days to change. So it's a mess when you change this data like that in the preferences, but you don't update them.
Yeah. Some of the best applications that I've seen allow you to change your time zone in your preferences. However, I never go for every trip, go there and start changing things. I live with it. But this is not the weirdest thing yet.
Of course.
And I'd like to start with a story about the next one because this is a fun one. We worked with a company who was doing systems to manage fleets. So basically ships, right? Ships traveling. And they noticed that sometimes the system was going down. And why was that? Because sometimes the date changes suddenly. And if you know enough about how time zones are structured, you know about the international dateline.
Mm-hmm.
So imagine you have to see the position of a ship or something like that, and the ship keeps changing the date because it switches between the on the dateline. Can you explain the dateline? Why do we have the dateline?
I think it's just a historical thing, because you need to start from zero somewhere, like
Yeah,
from UTC, and then you go around the globe, and then you have 23 hours, and you have again zero. So you need
exactly.
to start from somewhere.
You have the different time zones that are 15 minutes each. Usually we don't think about 15 minutes
Yeah,
each
we
because
think
we
about
usually
1
have
hour,
half
but
an hour, 1 hour, and so on. But in reality, time zones can be 15 minutes. And then they move around and they turn back, and then you need to change the date. You have no other way of maintaining a system that is consistent on the whole Earth. So because of that, you have the international dateline. So in case you are dealing with any moving objects,
like planes or ships or anything like that, right?
scooters.
Yeah.
I worked with a company producing software for scooters, and one of the conversations we had is, okay, you are now shipping your scooters only locally, but what will happen when you ship your scooters to Asia or Australia, and then you need to also have a kind of centralized system where you can see the positions of the scooters and all the things. Once again, time zones, international dateline, very important.
Yeah.
So know that your date may change in case you're dealing with anything that moves. So don't start to write logs.
Yeah, and it's a fun thing. Like, imagine you are there on the international dateline on the 1st of January, and then you go back to the 31st of December and back to the 1st of January. So it can happen. It's a test you need to write.
Or 28th to 29th February.
Exactly. So your systems might crash not just once, but keep crashing because you have these situations.
Okay, so this is a fun one, and I think many programmers, from what I noticed, they don't think about this thing. They don't even remember from geography lessons that there is an international dateline. There's a place where you change dates.
Yeah.
Please remember that we need software that works, especially that software that deals with shippings and navigation and all these things. Now, the weirdest one is the last one, which fortunately, until now, we didn't have a lot to do with it. And I'm saying until now, because until now, we didn't have things like, a basis on the moon. But once we start having people living in satellites or in orbit or any kind of planetary or satellite bases, this will start to become interesting. And I'm talking about relativistic time. So in case you don't know, I'm not going to go into the whole theory of relativity, but basically there are two things that can affect how time passes. One is the speed with which objects move relative to each other. The other one is the gravity, how much gravity there is in one point in the universe compared to the other points. And these two things affect the speed of time on the objects that are in space compared to Earth. And where we can see this, and I didn't know the precise numbers, but I looked for it. It's very, very interesting to see. Where we see this is in GPS. So GPS is a network of satellites that are giving you precise information about positioning, where you are. They give you the coordinates. That's how you know your phone or your car knows where you are and you can navigate. The problem is those satellites move at very fast speeds.
Yeah.
And the speed is so fast that they actually enter into the relativistic effect due to very fast speeds.
So they lose seconds, or they win seconds.
So just to tell you, again, I looked for these numbers, very interesting. In order to get accurate positioning, you need an accuracy on the satellite of 20 to 30 nanoseconds. It's fairly small. You need atomic clocks on the satellite to give you that. Due to the speed effect of relativity, the clocks will fall behind by 7 microseconds a day.
That's a lot.
So that's, if I'm computing correctly, that's at least 7,000 times
Yes.
Error.
Yes, exactly. That's a lot.
It's huge. But that's not all. Because the satellites are also in an area where gravity is less than on Earth.
So you have even more.
So you have a different kind, and you have the general relativity effect, which makes the clock on the satellite go faster actually faster this time. So it goes slower due to the speed, but goes faster by 45 microseconds per day.
Wow.
So to put this in perspective, you get therefore a difference per day of 38 microseconds. But to put this in perspective, if you don't do anything about this relativistic difference, you get a positioning error of 10 kilometers per day that accumulates every day.
And that's huge.
And that's huge. I mean, imagine.
Yes, you're in a different city.
Yes. If you live in Bucharest, it's the difference between the airport and the center.
Yeah.
More or less.
Yes.
So imagine just living one day the system. And because of this, two things happen. One of them is that the clocks on the satellite are actually fine-tuned to move slower than on Earth. The second thing that happens is that every GPS receiver has a small program that deals with this difference and tries to compensate for the relativistic difference. So until now, it wasn't a problem, right? We are not dealing with relativistic speeds, or our software is mostly on Earth, dealing with Earth stuff.
So maybe this is a NASA problem now. They have it, they kind of solved it, but it can become a bigger problem.
It can become a bigger problem once we get more into space. And imagine having things like a distributed system, microservices, but they are distributed between, let's say, the moon and the Earth, or Mars and the Earth.
Yeah, of course. The DateTime, that would be very fun.
In that case, the whole thing blows away. So how do you deal with DateTime? Because the date and time on Earth is very different from the movement of Mars and all that.
I guess you need another UTC.
You need a cosmic
TC
standard time. So you see how this is fairly fun, and why DateTime is much more complex than you can imagine. So how do you deal with this? Well, you have to test for it.
Yes, a lot.
You have to know that it exists. So in case you are dealing with any fast-moving objects that need software.
As far as I remember, even for very fast planes, this is an issue. For planes that, like for F-15s that go to Mach 3-4, it's becoming an issue when they fly for longer periods.
Yeah, it can affect the guidance system.
Exactly.
In that case. So, imagine shooting rockets out of a military plane and hitting a city instead of the training grounds. That would not be nice. So yeah, these are very, very serious things that you need to take into account when you write your code, and more so when you test your code. So what we advise in general is to, whenever you have date time in your functions as an input value, you start creating variations, and you test for 31st of December, you test for the 1st of January, you test for the 29th of February, you test for calling the method repeatedly, but first basically simulating daylight saving time.
Exactly. So you need to simulate when the click happens. So when you move from the one day to another, like from 1 year to another, from 29th December to the 1st of March, and so on. This is something that's a bit more difficult to test maybe, but you need to do that. You need to simulate that.
And of course, this assumes that you can inject the time as a variable. So never use system clock current time inside the function. Instead, pass a variable with the time.
And we need to be able to inject that time multiple ways if you want to test the passing of the date or of the year, because otherwise you just get stuck. So this is a problem where I think singleton can be an issue, because you might imagine you need the date time being a singleton.
Yes.
It will be very difficult to test if you have date time as a singleton.
Yeah, and it's not.
Exactly.
As you can see, it's not. So I guess this covers the, let's say, the serious part. Now you can also play with these things.
Of course.
And one of our favorite ideas has been to use Conway's Game of Life
during the Code Retreat, or the Global Day of Code Retreat.
And in Conway's Game of Life, in case you don't know, you have basically a universe, and you have some cells that can either live or die from one iteration to another, depending on various rules. And you get a lot of patterns. Sometimes you get more cells clumped into one place, sometimes they tend to dissipate and die, and so on. But a fun one would be to play with how fast time passes, depending on the concentration of cells in one area. And this will show you how difficult relativistic time can be. It's a simulation. I think it's a fun one. Have you done anything like that?
Yes, a few times while I was playing with wormholes, so that you have different places in the universe where you have time passes in a different way, and we were just simplifying it. So in one part was 1.2 times how fast the time would pass in the other place. So that means that in Conway's Game of Life you apply the rules at once for all the cells, but that means that you stop applying the rules at once, and maybe only because it's 1.2, each 5 times you will have to apply at once. So it's becoming very difficult. So you start understanding that in fact applying all the rules, which is called the tick moment in Conway's Game of Life, when creating a new generation, is not something that needs to happen only once. So it's more like an event that happens depending on where you are.
Yes.
So everything changes.
That's actually the fun thing, because in a typical implementation you'd call tick again and again and again, but in this implementation you basically disconnect the time axis from the ticks.
Yeah.
And that's a different idea. All right, so this is it. This is just a primer, by the way.
Yes.
DateTime is incredibly complex. We just wanted to go through some of the most common things that we see in code and with our clients that lead to bugs, lead to problems in production that affect real users, sometimes governments,
Yeah.
for a day or even for longer, and sometimes have very weird effects, like ships stopping in the middle of the ocean, or and you need to reboot your system to be able to move. So pay a lot of attention to these things, and of course they depend on the type of product that you are doing. But I hope with this you'll find more appreciation for the complexity that is DateTime. Very complex. Thank you. I hope to see you again soon. If you have any ideas about other design challenges that you are facing,
let
how
us
to
know.
model things, to me, I think that's the most fun topic I can think of. How to test things in code, how to structure your code to deal with various challenges. And so until next time, remember to think, design, and work smart.